So you have a breadboard here, you have a dual supply here, you have a current source because you want to give a current input, you have a current source here. You can give currents in the order of milliamperes or microamperes by increasing the values, and you have a multimeter here which is already set in milliamperes so that it can measure currents in milliampere. You have the op amp and the resistors. Let me just form the circuit. So the op amp goes over here and the wiring is done. This is a circuit that you have here. So instead of the load resistance, I have put the multimeter. The multimeter forms the load. This R2 is here 10K, R1 is 1K. So the gain is going to be 1 plus R2 by R1, 1 plus 10K divided by 1K. 10K divided by 1K is 10. So 1 plus 10 is 11. Therefore the gain of the amplifier is 11. So you can also see here, this is 10K which is coming from 6 to 2 terminal. This is a feedback loop, right? Pin number 6 is the output, pin number 2 is the input, the inverting input. So you put a negative feedback connecting these two through the resistor 10K, and you have the other resistor here which is the 1K resistor. So this is a 1K, and so the gain will have to be 11. Now I switch on the power supply, dual supply and the multimeter, so I can start giving the voltages. Now let me start from microamperes. So if I increase here, now it is 100 microamperes. As you can see, the current input is 100 microampere, and if you multiply by 100 microampere by 11, it will be 1100 microampere or 1.1 milliampere. So you can see the reading is around 1 milliampere. If I increase to 200, it will be 2.2 milliamperes actually. So as you increase the current, you can see the output current also increases nearly 10 times. It should be actually 11 times. It depends on the actual values of the resistors. If there are some variations because of the tolerance, then this factor cannot be exactly 10, it can be slightly less or more. Perhaps that is the reason why you are getting only 10 times and not 11 times. It depends on the typical actual values of the resistor, which has to be measured using a multimeter. Right. Now let me quickly come down and then let me go to milliamperes. Let us give milliamperes. Now I give 1 milliampere and the output current is, this is 1 milliampere, the output current is 10 milliamperes. So if I now go to 2 milliamperes, it is 20 milliamperes, 3 milliamperes means 30 milliamperes. So you can see the output current is increasing nearly 10 times, which is given by 1 plus R2 by R1 approximately. So this is an example of a current amplifier constructed with the op amp, and the wiring is very simple. You can see this is the ground, this top one, and this is the plus VCC, and this is the minus VCC, the blue line, and so the pin number 4 is connected to the bottom, which is a minus VCC, and the pin number 7 is connected to plus VCC, and you have the input current here and the feedback loop, etc. So the wiring is exactly same as what you have here, and so this is a very current amplifier.